Hello engineers, this is Zubair. In this video, we will see about the development length in beam and column and slab. Okay. So first, we will see what is development length. What is development length? Okay. See here, the length of embedment. Here the bar is going inside the beam. The length of embedment necessary to develop the full tensile strength of the bar. The length of embedment necessary to develop the full tensile strength of the bar, controlled by either pull out or splitting. So we are providing development length to control by either pull out or splitting of the bar. Okay, so a certain minimum length of the bar called development length. We are calling it is LD. Okay, so it has to be provided on either side of point of maximum steel stress to prevent the bar from pulling out under tension. Under tension or pushing in under compression. Okay, so here we have a recommendation. We have a clause in IS 456. We need to take development length as per this formula. This formula is depending on the we are taking what grade of concrete and dia of bar and grade of steel. Okay, grade of concrete, dia of bar and grade of steel. Okay, we have a values for according to the grade of concrete. Okay, we'll see one problem on this. We'll see one example on this. Here we have a simply supported beam span having 8 meter. That beam having 6 number of dia of bar. You can see here 6 number of, this is the beam, 6 number of dia of bar at center. Okay, at center we have 6 number of dia of bar. Okay, at support we have 3 number of dia of bar 25 mm, 3 number of 25 mm dia of bar. Okay, so grade of concrete M20 and grade of steel 415. We need the load acting on the beam is 50 kilonewton per meter. We need to find the development length for this beam. We are having this much of data. So we need to take this load as a factored load, multiply by 1.5. Okay, so we will get the factored load here 75 kilonewton per meter. Okay, so first of all we need to find the bending moment and shear force. We have a formula, bending moment formula for simply supported beam, WL square by 8. 75 into 8 square divided by 8. We will get the value 6000 kilonewton meter. This is the maximum bending moment. And maximum shear force, WL by 2, 75 into 8 divided by 2, 300 kilonewton. Okay. So moment resistance of the bar continued into the support. We have a formula that we will get 300 kilonewton meter. Okay, so we need to find now development length of for 25 mm dia of bar. Use M20 grade of concrete Fe 415. We have a formula according to the IS 456. You can see here according to the IS 456. Okay, see 25 dia of bar, stress in steel, dia of bar into stress in steel, and 4 divided by 4 into toe BD. Okay, what is toe BD? So this toe BD value is depending on the depending on the what grade of concrete. See, our dia of bar is 25 mm. Stress in steel 0.87 into Fy means 415, and divided by 4 into this toe BD value. You can see in this toe BD value in IS 456 here there's that design bond stress for M20 grade of concrete we have 1.2. For M20 grade of concrete, the toe BD value is 1.2. Okay, so there we have taken, see for M20 grade of concrete, the toe BD value is 1.2. The toe BD value is, you can see here, 1.2 for M20 grade of concrete. Okay, so that toe BD value need to increase 60%. This value 1.2 value should need to increase 60% for deformed bar. For what? Deformed bar. Because this 1.2 value is for plain bar. What is for plain bar? So we are using deformed bar. So this value we need to increase 60%. This value we need to increase this 60%. If you increase this value 60%, you will get 1.92 Newton per mm square. Okay, here you put this value and will get that development length 1175 mm. Okay, now check for LD at support. As per clause number 26 IS 456, we need to increase 30% for this LD. Okay, you will get this 1300 mm square okay, the length of development length. Okay, this is the required, this is the provide, required, this is the provide. We are providing this much of, that means it is okay. So we can use this formula for using finding the development length of the bar. Okay, now we'll see in compression member. Compression member. Okay, see here, development length for compression. So here we have an example. You can see, calculate the anchorage length or development length of a 20 mm diaphragm bar, a grade Fe 500. In compression means column bar. A grade of M40 grade of concrete. Here assume stress in steel is 0.7 Fi. 0.75 Fi. You can take 0.87 Fi. Here has given assuming 0.875 Fi. Okay, see here stress in steel 0.75 Fi means 500. Here we have Fe 500, that is 375 Newton per mm square. The design bond stress for M20 grade of concrete. The design bond stress for M20 grade of concrete, you can say M40 grade of concrete is 1.9. The design bond stress toe BD for M40 grade of concrete is 1.9. Okay, see 1.9 here, 1.9 according to the IS 456. Now we need to increase this 1.9. As I told you earlier, we need to increase in this 1.9 for 60%. What? For 60%, because this value is for plain bar. We are using a deformed bar. For deformed bar we need to increase 60%. We need to increase what? 60%. Okay, so again for this bar we need to increase 25% for compression. 60% we are increasing for that, we are using HSD bar, deformed bar. Okay, that means okay, we are increase 1.9, we are increasing 60%. We are increasing what? 60% of this for deformed bar. Again for this value we need to increase for 25% because of compression. Because of what? Compression. Because of compression. Here you can see toe BD is equals to 1.9 is actual value, that is for plain bar value, that is according to the IS 456. Toe BD is equals to 1.9. 1.9 is from IS 456 for plain bar into 25% means for compression. 25% is for compression zone. Okay, now into 60% for HSD bar, because we are using high deformed bar, that's why we are increasing 60%. That toe BD value will come 3.8 Newton per mm square. 3.8 Newton per mm square. If you put this value in this formula, LD formula, the die of bar is 20, stress in steel is 375 Newton per mm square. That 4 into 3.8. 4 into 3.8. You will get the 493. We'll take now round figure 500 mm. That development bar. We need to provide 500 mm development of the length. Here you need to provide what in compression member the 500 mm the length of anchorage length of the bar. Okay, this is all about the development length. Okay, so for more videos you can subscribe and share these videos, and thank you very much.